Hello guys, it's JohnnyTime and welcome to a new CTF walkthrough solution series. Today we're gonna start a new series where we're going to solve together the famous Ethernaut challenge, smart contract hacking challenge by OpenZeppelin. And I've got some good news for you. In this series, we are going to solve the Ethernaut challenge with Foundry. So you're getting two birds in one shot. You're gonna learn smart contract hacking, meanwhile learning how to work with the most famous framework out there with Foundry. As I mentioned, Ethernaut is one of the most famous CTFs for smart contract hacking and auditing by OpenZeppelin, and in every episode of the series, we will solve another challenge. This is the first video where I'm going to explain to you what is Ethernaut, how it looks like. We're going to tackle the first challenge number 0, Hello Ethernaut, and we're going to set up our environment, our Foundry framework and environment to create POCs and solve on-chain on Goerli testnet blockchain every single challenge using Foundry. So it's gonna be awesome. So if you want to learn how to get started with Ethernaut and how to solve the challenge, this is the video for you. And if you're interested in more awesome smart contract hacking and auditing content, definitely subscribe to the channel and turn on the bell notification button. Now without further ado, let's get started. So this is Ethernaut. As you can see, it's a CTF challenge by OpenZeppelin that consists of 29 different levels. The more you progress in the levels, the harder they get, and once you complete every level, you learn new things about smart contract hacking and smart contract security. In my opinion, CTFs are the best ways to practice and increase and enhance your skills in smart contract hacking and security. Now, how it works. Let's click on the first challenge, Hello Ethernaut, to understand how we can start playing the CTF and solving those challenges. So this is the first challenge, Hello Ethernaut, and this is actually a very easy challenge just to get you started, to get used, so you can get used to how to solve this challenge in Ethernaut. The first thing you need to do is set up your Metamask browser. This CTF is going to be executed on Goerli Ethereum testnet. You will need a Metamask wallet in order to interact with the Goerli blockchain. It's the Ethereum testnet blockchain, and to get smart contracts to hack and send transactions to hack these smart contracts on the Ethereum Goerli testnet blockchain. So you can just click the link here to install the Metamask browser extension if you don't have, and follow the setup instructions to set up a new wallet. If you're not sure how to do it, check my other video tutorial, complete Metamask setup video tutorial. As you can see, this is my Metamask wallet and I have here account number 3, and in my network I'm already connected to Goerli network. You need to make sure to tap here to make sure it's on show testnet network so you can see Goerli and Sepolia, and then select Goerli testnet network. Basically, using the Metamask wallet, you can switch RPC network to work with different EVM-based blockchains. And for this challenge, we'll need Goerli network. So this is our wallet that we are going to play with, and this is our player account that we will solve the challenges with. This is our address, and we also have a private key with this wallet that we will later on integrate with our Foundry project. So the next thing we need to do is to open our browser console. So in Mac, I'm going to use the shortcut Command Option I. You can simply just do right click and then inspect elements to any point on your screen to open the console. And this is how the console looks like. As you can see, we have some nice message, Hello Ethernaut, we have the level address, and as it mentioned here, we can just write player to receive our player address. And this is our player address that we're going to play the CTF with, and it's actually the same address that we see over here. This is our wallet address that is connected currently to the Ethernaut website. I can just copy and paste it and show you that it's the same address. As you can see, this is the Metamask address, and this is the address that when we wrote player, we got. It's the exact same address. Now we have different console commands which we can use, such as get balance, and if it's asynchronous request, we need to use await before, so we can do something like this: await get balance of the player, and it will give us the balance, which is 1.13 ETH. And if we want to get all the commands, we can just click just write the command help, and this is where we can get all the different commands that are available for us through the challenge. So we have the Ethernaut contract, which is the main factory, the biggest contract of all the challenges. And every time we call him, we tell him create new instance for every single level, and it will create a dedicated smart contract for the level for us. So now we are on level 2. We will call Ethernaut with create new instance or get new instance, and will deploy a new instance of level 0 for us, and use smart contract that we will need to hack. You can look at it like the factory, level factory smart contract. Now, the thing is that in every level, we will have an instance object that represents this level. So we have the contract and we have the instance object. So currently, if I will write in the console contract, we'll see we don't have a contract object yet because no contract set. Go to level and click get new instance, because we just did not deploy our instance level. Same as if we write instance, we will see it's undefined because we don't have the current contract address. So we'll have to go back to the website and click here, get new instance. As you can see, it will prompt our Metamask wallet to send a new transaction to the factory main Ethernaut smart contract to deploy a new level instance for us. It will take a while. The transaction will be broadcasted to the blockchain, and after a few seconds, this transaction should be mined and will receive a new smart contract to hack. As you can see, now we have a new button, submit instance, and we should click this button after we completed all the objectives. After we achieved the required state, we'll click this button to make sure that we did everything correctly and we were able to successfully pass the level. Now, if we open the console again, we see that we sent some transactions and now we have instance address. If I will write instance, I will get this address. And if I'll write also contract.address, I will receive the same address. It's the same address, and contract is just the object that includes also the ABI and all the available functions for us. Now, this is the first level, the easiest level that is supposed to teach us how to go through the Ethernaut challenges. And we can see here that we can interact with the contract by calling the function .info. So let's call the info function, and it returns a promise. And if we don't want to receive a promise, we can just add here await. And the return value of this info function is you will find what you need in info1. Okay, so I can do await contract.info1. And then it goes on and try info2. So this is a bit annoying. They want us to go through different functions, and we are a bit smart on that. We want to bypass all those struggles. So I'm just gonna take a look at the contract object and see what functions it exists. So I just clicked here, I just called contract and open whatever I got. And let's see what we have. We have different stuff over here. We have address, and we also have the ABI. The ABI will show us the interface of all the functions which we can call in this particular instance level contract. So I'm going to open here the ABI. And as you can see, we have all the different functions which we can call. Instead of going by info, info1, info2, info42, infonum, we can already see that this contract has some kind of function that's called authenticate. And as we can see, when we open this authenticate function, we can see that it receives an input, one input, which is a string called pass key. So we need to call this authenticate function with some kind of password. Now, we don't know what is the password, but if we observe a bit deeper into the contract functions, we see there is a function password over here that returns a string. So let's try to call the password function to receive the string, right? So let's do the following. I will do await contract.password. And let's see what we get. We get Ethernaut 0. So this is probably the password, and now we can try and pass this password to the authenticate function. So I'm gonna do await contract.authenticate, and I'm going to pass this password Ethernaut 0 that we received from the password function. And now, obviously, we need to change the state. We're calling not a view function, but a function that will change the state and will try to solve the challenge. Therefore, the Metamask has been prompted for us. So I will have to click here, confirm, and send the transaction to the authenticate function and see what happens. Now, the transaction is being sent in the background, and we can see that the transaction was mined and confirmed successfully. And now we can just click here, submit instance, to check if we succeeded. So let's do it. Let's do submit challenge and confirm, just to see if it was the right password. And this is what we were supposed to do in this challenge. And we did it, guys. As you can see, we got a prompt, well done, well done, well done, which means that we successfully completed the first challenge, challenge number 0. And now, as you can see, we have also the smart contract code. In this challenge, we didn't get the contract code only once we solved it, but in the next challenges, we'll receive the contract code in advance. But we did not finish yet. Do not go anywhere. So we completed level 0, but as I mentioned, we want to set up our Foundry framework and see how we can solve this challenge and the upcoming levels through Foundry, so we can get 2 birds, 1 shot. We can learn smart contract hacking while learning how to work with the most famous framework for smart contract hacking development and auditing. But before we set up our Foundry repository and framework, I want to tell you that if you are serious about smart contract hacking and auditing, and you want to take your skills to the next level, you should definitely check out the complete smart contract hacking course. This course comes with 30 different chapters and more than 50 hands-on exercises that are gonna make sure that you master the skill of smart contract hacking. As well, it comes with a certificate that you can use to showcase your skills and increase your chances of getting a smart contract auditor or security researcher job. And the creme de la creme, in addition, you get access to the best Web3 security community out there, where you can meet other students, ask questions, and engage with other professionals in the fields so we can embark on the journey together. Get a special discount link in the description below. Alright guys, now let's set up our Foundry framework, but before we do that, let's see how it's going to work, how we're gonna solve the challenge, create POCs that submit the levels and solve every challenge on chain, on Goerli testnet blockchain. So we've already done step 1. We set up our Metamask wallet and we have our EOA externally owned account. We have the Ethernaut website and the main Ethernaut factory smart contract. For every level, we're going to go to the website and manually get new instance. We will click the get new instance button, and then it will deploy a level instance for us that will have an address. Then we will have our Foundry local repository in VS Code. We'll set up the Foundry with Goerli RPC. We will export the private key from our Metamask wallet and add it to our Foundry project to the environment variable. And then we'll have 2 files for every challenge. Sometimes it will be more files. We'll have the smart contract level code under the source folder, and then the solution will be under the script folder. We'll create a smart contract level x solution.s.sol, which will be the script that will solve and interact with the level challenge smart contract. Then we will run the script on our Foundry folder, and it will send a transaction, the necessary transaction, to the Goerli chain. We will broadcast the transactions from our Foundry project directly to the Goerli chain to successfully do all the objectives and all the steps of the challenge. Then in step 3, we'll go back to the website with our Metamask wallet and we will click the submit instance button to make sure that we were able to achieve all the objectives and completely solve the challenge. This is how we're going to do it with step 1, step 2, and step 3 in every single challenge. And now let's set up our Foundry repository. So you can definitely set up a new repository yourself, but I highly recommend you to use my repository that is already set up with a new Foundry project. So you can head over to the description and go to this GitHub repository and clone it to your local machine using git clone. You can click here, code, and then git clone to your terminal if you're on Mac or Linux, or to your CMD if you're on Windows. So you're gonna clone this repository to your local machine. So as you can see, I already cloned the repository to my local machine. And if you don't have Foundry installed already in your system, you will have to install Foundry. So the first command is this one, to download the Foundry last release and then throw this output to bash. This is Mac or Linux command. I'm not gonna run it right now because I already have Foundry installed. And then the next command that you're going to run is Foundry app, to make sure that you update your Foundry to the most up-to-date version. I'm gonna run it and make sure that my Foundry is up to date. So it's gonna download the latest version of Forge, Cast, Anvil, and Chisel and update the version on my machine. Now, the next thing you need to do is to create a .env file and configure it. So now this, obviously the content here is going to be blurred because it's my private key and Etherscan private key. We have here three variables. One is the private key, the second one is the Etherscan key, and the third one is my address. So you want to set up this new env file in the repository folder. As you can see, I open it with VS Code, my favorite code editor and IDE. You can use whatever editor you want. The most important is that you will create this new env file and submit your private key, Etherscan key, and my address. So my address is the most simple. You're just gonna go here to your Metamask wallet, to your selected account, copy the address, and then paste it over here. Now, in order to create an Etherscan key, you will have to go to Etherscan and then create an account with your email, and then go here to API keys. Obviously, you have to be logged in and create here add, and here we'll just do Ethernaut. So create new API key, and now you will have this Ethernaut API key, which you can copy and paste in your .env file. To get a private key of this account, you will have to open your Metamask wallet again. Click here on this button to open all the accounts, and here on the selected account, the account that is connected to the Ethernaut challenge, click here the three dots and then account details. Now you need to click here, show private key, submit your Metamask password for security, and you need to hold it, another security measure. You're gonna hold this button, and once you complete it, you will have your private key, which you can click here to copy and then paste here in your env file. Once you complete it, set up private key, Etherscan key, and my address, you can close the env file and you're set to go. Beautiful, guys. Now let's solve the level 0 challenge through Foundry, so we can see how we can solve the challenges, the different challenges through Foundry. First of all, we need to create a smart contract in the SRC folder. So I'm creating a new file and I will call it level0.sol. So this will be the level 0 smart contract, and I'm simply going to copy this smart contract from the website. We already submitted it, so we have the code. I'm going to copy it and save. Awesome. We have the instance of the smart contract, and now I want to create a new file in the script folder. This will be the smart contract that solves the challenge and interacts with the level smart contract. So I'll create a new file and we'll call it level0 solution.s.sol. S stands for script. This is the best practice of how to create script files. Now, the first thing I'm going to do is define the pragma, the Solidity version, and then I'm going to import the smart contract of the level itself. So I will do import /src, and then we have level0.sol. Now I'm going to import two more built-in Foundry libraries that I'm going to use, the script library and the console. Through the challenges, I'm going to use console log to print different stuff in the challenge, and the script will be used to get all the Foundry different cheat codes and beautiful things that we can do with the VM and manipulate the blockchain through the Foundry cheat codes. And I'm going to create a new contract level0 solution is script. I'm going to inherit with script, so I will have by default all the different challenges, all the different functions that script gives me in the contract. And in this contract, I will have to define a run function. This is the default function that will be executed once I run the script. And if you want to learn more about Foundry and how it works, you can either learn through these videos or go to the Foundry book, which is an amazing way to learn how to work with Foundry. Just Foundry book, search in Google. Okay, now before we start working on the run function, we want to create the level instance. So I'm going to define here a new state variable. It will be level 0, public level 0, and it equals level 0. I'm going to create a new instance of level 0. And now the thing is that I need to get the smart contract address that is deployed on the Goerli blockchain. We'll have to do it for every single level. So I'm going back to my browser. I'm opening the console over here. I'm going to do contract.address. This is one option. I'll just click here instance. Are the two options to extract the instance level smart contract address. I'm going to copy it and paste it directly here in my Foundry script file. Now, let's first print the password from the level that we received previously. So I'm going to do console.log and going to print here the password. So I'll do password. And in order to get a password, I can simply just call the instance, the level object.password to receive the password because it's a public variable. We can see it over here. It's string public password. Then the next thing we want to do is to use the cheat code vm.startBroadcast using the vm-env-uint private key. What we are doing here, basically, first we retrieve from the environment variable that we set up in our env file, the private key of the Metamask wallet. And then we use the start broadcast command to make sure that we are sending the transaction from the player account that is associated with this private key that we just defined. So we are using these two cheat codes in order to make sure that the transactions will be sent to the real contract in the Goerli blockchain. Now, the next thing I want to do is to complete the level. So I will do level 0.authenticate and I will retrieve the password again. Let's do something like this. So instead of doing this, I will do string memory and this will be password. And now I can use the same local variable both to print it over here in the console and both to use it for the authenticate function. Beautiful. Now that we authenticate, we can stop the broadcast. So I'll do vm.stop broadcast. And this should be our solution for the level 0 challenge. Now, in order to test our solution, we can go to the terminal, either in our terminal or within VS Code, and we can do something like forge script. Then we're going to do the script folder and select our script. If you want to add more verbose information and more debug information, you can always use -v or 2 V's or 3 V's or 4 V's. The more V's you have, up to 4 V's, you will have more detailed output. Alright guys, I had two small issues. First, the smart contract of the level, the name was instance and we mentioned it here as level 0. So I went to the level 0 smart contract and changed it to level 0. The second issue is with our private key. So when we copy the private key from Metamask, when we exploit from Metamask, we need to add 0x so it will know how to treat it as hex file and not as integer. So make sure to copy your private key and then add before 0x to your env file. And now that we completed these two things, I'm gonna run the test again. So I'm going to run forge script, then the script that we have level 0 solution, and I'm gonna add a lot of verbose. So I'm gonna add 4 V's and see what we get over here. So the transaction is being executed now locally in a local clone of the Goerli, clone of the Goerli blockchain. It's not being broadcasted because we didn't use the broadcast command, but this is to test to see if everything works as expected, if we're able to load the private key, to load the smart contracts from the blockchain, and to solve the challenge. So before we broadcast, we want to make sure that we did everything correct. And as we can see, it's very verbal. The verbose mode is on. So you can see every single call here. This is the beautiful thing in Foundry. And we can see the console log over here, and here we have the logs. So this is the password that we just printed using console log, and we have all the traces, every single call that we made in the smart contract, and we even have a summary of how much gas it's going to cost us if we will broadcast it to the blockchain. This is just a simulation. So, and we can also see here that if we want to broadcast it to the blockchain, we need to use the broadcast command. So the next thing that we want to do to solve the challenge and broadcast this solution to the blockchain itself, we want to just add here -- broadcast and run. I had a typo, so broadcast. So I will click enter, and now it will broadcast this transaction to the actual blockchain. It's gonna execute this script instead of locally in my forked Goerli blockchain, in the blockchain itself, in the Goerli blockchain, using the RPC URL that we have here in our Foundry TOML file. This is the anchor ETH Goerli RPC, and we can see that it succeeded, guys. We can see that the transaction was broadcasted to the blockchain, and it also confirmed. So now if we go back to the website, we're supposed to complete the level. Now we already completed this level, so we cannot check it actually. But if we wouldn't call the authenticate function and send a transaction through the Metamask wallet, and we will just do it through the Foundry, then if we will click submit new instance, we'll see that we completed the challenge. You will see in the next solutions, in the next challenges, in the next video. So make sure to watch all the series to see how you can solve all the Ethernaut challenges using Foundry in this exact series. Now, I know it was a bit long, but we went through a lot of things of what is Ethernaut, how to get started with Ethernaut, how to solve the level 0 challenge and work with the console and with your Metamask wallet, and of course, the most important thing, how to set up our environment with Foundry to solve all the challenges using Foundry so you can get 2 birds in 1 shot. Again, make sure to subscribe and follow all the tutorials in the series, and if you enjoyed this video, make sure to smash the like button so more people can enjoy it and the algorithm will push them this video so they can get educated. Thank you so much, and I will see you in the next tutorial. Bye bye.